Ray's astrophotography has just exposed something NASA conveniently left out of their press conference about Comet 3I Atlas. This independent astrophotographer is bringing forward critical data that changes everything we thought we knew about this interstellar visitor. We're about to dive into missing evidence from the stereo satellite showing the comet got 400 times brighter than normal comets. Secret imagery from the Punch satellites that NASA barely mentioned. And a close Jupiter encounter that only a handful of comets in history have survived. Ray has captured images from his backyard telescope that rival what we're seeing from space agencies, and he's asking the uncomfortable questions about why certain details were downplayed. This isn't just another comet story. This is about a massive interstellar object from another solar system giving us a once-in-a-lifetime research opportunity. And we're going to see exactly what the official narrative missed. I hope it is going to be a bit better in the morning. So, I'll take more captures of Comet 3 Atlas. I was looking at the data that NASA posted during the press conference. They missed a lot of stuff when they were talking about Comet 3I. I wanted to highlight some of those important things that we missed during that press conference. We wanted to go back in time, so it came in a hyperbolic trajectory, coming all the way from the top of the solar system and passing Neptune orbit. If you back calculate, it might have came in around 2017, and it must be passing all the way, and we started seeing that in 2025, and when it came in closer and closer to the sun, in the March time frame, it was having a perihelion with sun. So it is coming closer point to the closest point to the sun. During that time, NASA's satellite, the Sirio, did take picture, and when you look at the pictures, the Comet 3 Atlas got 400 times brighter than a normal comet that generally brightens around like maybe 100 times. Here's what NASA didn't emphasize enough during their press conference. Comet 3I Atlas experienced a brightness explosion that defies normal comet behavior. The stereo satellite captured this object becoming 400 times brighter than typical comets, which usually only brighten about 100 times. Even compared to Comet C2020 F3 Swan 3I Atlas was dramatically more active. But here's the really strange part that Rai points out, the color transformation. This comet shifted from red to blue, completely skipping green in the spectrum. That's not normal physics for a regular comet. This color jump indicates a unique chemical composition, something fundamentally different from what we see in comets born in our solar system. The fact that NASA's presentation glossed over this spectral anomaly raises questions. When you have an interstellar object behaving this differently, every detail about its chemical makeup matters for understanding what other solar systems are made of. Ray's right to call this out. The 400x brightness surge and bizarre color shift deserve center stage in that press conference, not a footnote. So even if you compare with the Comet R2 Swan, this one got 400 times brighter. It changed from red to blue, like in between it skipped the green and it went back to blue. I think that we could have highlighted it because of the unique chemical composition that this comet has. And then, once it completed the perihelion with the sun, it moved onto the Mars, and you saw the pictures of Mars Reconnaissance Orbiter and NASA released that blob of the picture taken from the Mars Reconnaissance Orbiter MRO, and there wasn't much details there, and there is a lot of backlash from everyone asking for more details. Actually, there is an important point there that we all missed during March 2025 using SpaceX. There is a non-profit research institute called Southwest Research Institute. It sent 4 satellites. They are called Punch. And those 4 satellites go and stay in the orbit of Earth just above 600 kilometers from the ground. So they are designed to take the solar wind 3D model using those 4 satellites. Now, those 4 satellites are designed to observe the solar wind. This is where things get really interesting. The Southwest Research Institute launched 4 Punch satellites in March 2025 via SpaceX, positioned just 600 kilometers above Earth. These satellites are specifically designed to create 3D models of solar wind. But during the Mars 3I Atlas conjunction, they were redirected to capture something extraordinary. Ray has done the calculations from these images. The coma of 3I Atlas measures approximately 17,000 km in diameter. That's significantly larger than Earth's 12,500 km diameter. Let that sink in. We're talking about a cloud of gas and dust around this comet that dwarfs our entire planet. The Punch satellite imagery shows 3I Atlas as an incredibly bright object with Mars passing across the frame. You're seeing the dark side of Mars because these satellites face the sun. Rai makes a crucial observation here. If these satellites at 600 kilometers above Earth can see 3I Atlas, this clearly alongside Mars, imagine the perspective from Mars itself. From the Martian surface, this comet would appear absolutely ginormous. And here's Ray's key criticism. These Punch satellite images existed before NASA's press conference, but weren't featured prominently. The visual impact of seeing 3I Atlas's true scale compared to Mars would have fundamentally changed public understanding of what we're dealing with. So during the Mars conjunction with the comet-free Atlas, they did pointed out their satellites towards Mars, and they took some pictures, and those are wonderful pictures. In my previous video, I was actually comparing the pictures that I had taken, and I was calculating how big the coma of this Comet 3 Atlas is, and I came to like around 17 Zohosian kilometers diameter. Earth is around 12,500 kilometers. So it's a much bigger coma than the Earth itself. So when I was looking at this picture taken by the Punch satellites, you'll see on the top the Comet 3 Atlas being very bright, and you see the Mars going across. Now you are seeing the backside of the Mars because these satellites are designed to look at the sun. So you are seeing Mars going by and the sun is on the other side. But you see that bright object there, which is the Comet 3 Atlas. That picture was taken before that press conference, and that would have been very impactful for people to understand how big Comet 3 Atlas is. Not only that, think about it. Let's say these satellites are 600 kilometers above the Earth and they are looking at sun, and when they look at this Mars and 3I the 3 is on the top, Mars is going by right, imagine you start flying towards Mars, 3 Atlas is going to be bigger as well, and imagine you stand on the Mars and taking a look at Comet 3, it's going to be a ginormous, but it's something that I think you do not learn from the land torture, that it's something from or not learn from and want. I don't think there is any talk. There was a press statement released afterwards releasing these pictures, but the impact of it wasn't there in the press conference. It should have been Comet was moving away from Mars. Now coming towards Earth and going towards Jupiter, right when we are seeing the brightness of the Comet 3I going up and up, like why it is so bright, because it is so big rays connecting dots that the NASA presentation left scattered. Yes, 3I Atlas is bright, but the brightness means something when you understand the scale. This isn't just any comet. When you compare it to the largest comets ever cataloged from our solar system, 3E Atlas belongs in that top tier category. But here's what makes it scientifically priceless. It's interstellar. It came from a completely different solar system formed around a different star from a different primordial disk of materials. This comet is essentially a 4.6 billion year old artifact from another star system, and it's massive enough that we can actually study its composition in detail. Rai emphasizes that this is a unique research opportunity. We're not just looking at another comet. We're analyzing the building blocks of another solar system. The chemical composition data we gather from 3 Atlas tells us what materials existed around a distant star billions of years ago. This kind of opportunity is extraordinarily rare. The fact that it's this large means we can get spectroscopic data. We can observe outgassing patterns. We can study how materials from another stellar neighborhood behave. Ray's frustration is justified. NASA's presentation should have hammered home how rare this event truly is. How big it is, you will only know when you compare that with the other comets around us. The solar system comets that we have seen and bigger comets, if you categorize them in the first category of bigger ones, comet 3A also goes in there, but it is an interstellar object. So being interstellar, coming from a different solar system, not ours, being that massive, you have a unique opportunity to take a look at the chemical composition of this really old relic that we are looking at. And that would have been very impactful to understand the importance of how rare this event can be, because you are seeing this massive object coming through our solar system, and we have an opportunity to take pictures, understand, do some research on what it is. Now, once it passed through the Mars, it is going to give us a better pictures from the Earth. It goes towards Jupiter, and when it goes towards Jupiter, there was quite a bit of noise around it, is going closer to the Hill radius of the Jupiter. Hill radius of Jupiter planet Jupiter is very, very big. Jupiter itself is a huge planet, and the Hill radius is much bigger. Any that is going out of our solar system may be passing the Hill radius. Hundreds comets pass the Hill all time. No, that's not unique about the 3I Atlas. The 3 Atlas is not just going passing the Hill radius comet. 3I Atlas is going very close to the Jupiter planet itself and going. And how many times and how many comets have we seen coming this close to the Jupiter and passing very small number? You can count maybe 2 or 3 comets that went this close to Jupiter and moving away. I have a lot of updates on Comet 3 Atlas. So click on the notifications button and like button. You get notification when I post a new video on the Comet 3 Atlas. Let me show you the data that I captured. So this is the data that I collected. I removed the background stars and I just wanted to see how this comet is going to look. Let's clear up the Jupiter encounter confusion that Rai addresses. There was significant noise in the media about 3I Atlas approaching Jupiter's Hillsphere, the region where Jupiter's gravity dominates. But Ray points out that hundreds, even thousands of comets pass through planetary Hillspheres all the time. That's not special. What is special about 3I Atlas is that it's not just passing through Jupiter's gravitational influence zone. It's going extremely close to Jupiter itself. This is exceptionally rare. Rai mentions you can count on one hand how many comets have made such close approaches to Jupiter and survived the encounter. Maybe 2 or 3 in recorded history. When a comet passes that close to Jupiter, the gravitational forces are immense. Jupiter could tear it apart, alter its trajectory dramatically, or even capture it. The fact that 3I Atlas is making this close pass adds another layer to its significance. We're watching an interstellar object thread the needle past the solar system's largest planet. This isn't just about Hill radius mathematics. This is a real physical close encounter with potential consequences for the comet structure and trajectory. Now Ray shows us what an independent researcher can accomplish. He's processed his backyard telescope data by removing background stars to isolate the comet itself, and the results are remarkable. He's not interested in the tail, not interested in the overall spectacle. He's focused specifically on the coma and the core structure. What Ray discovered in his processed images is fascinating. The core region shows a distinct pointed shape. It's not just a diffuse blob. There's actual structure visible in the central region of the coma. This pointedness suggests something about the nucleus shape or the way material is being ejected. Ray compares his observations to the Hubble Space Telescope images and finds consistency. That same pointed structure appears in Hubble's captures. The fact that a backyard astrophotographer is seeing similar structural details to what a space-based observatory sees, validates both the quality of Ray's work and the reality of this structural feature. As 3I Atlas approaches closer to Earth, this pointed core region is becoming more apparent. Ray suspects we might be seeing the actual shape of the nucleus manifesting through the coma, or at least the directionality of the most active auging. This is citizen science at its finest, independent verification of professional observations without any background stars. And to my surprise, it is actually quite beautiful and brighter. You can see the comet itself. I'm not interested in the tail. I'm not interested in anything else except the coma of the comet and how big and impactful it is. And the most important thing is you'll start seeing the core of it in the middle right, which is a little bit pointed. So I'm going to take more pictures of this data. This is now looking like that Hubble picture coma that we saw in our previous videos. So as it is coming closer and closer, the central region of the comet is showing that pointiness, right, like the front like this. So that's what I was interested looking at it. That's what I was trying to understand how it is. It's not just a blob in between. It's this right. So I'll show you the comparison of what I did with the Hubble images that were taken. These were the H images that were taken, and take a look at these ones. You see that pointedness of the area, right? That's what I was going after. There is something there that we might need to, and obviously you can see it spinning as well. When we start looking at this comet, we might actually see the shape of the comet more and more clearly when it comes closer to us. The nose of it is actually more pointed than the rest of the body, right? It's kind of interesting to see that. Or maybe I'm just looking at it that way. It may be an illusion for me. But this is the picture that was taken by Hubble, and all we are doing is trying to take a look at it. And that's what I'm seeing now as it gets closer and closer. Hubble is an 8M telescope. It's like 16 times more massive than the backyard telescope I'm using. If Hubble takes a look at this comet now, it can take a lot more details and great captures of it. No one can resolve it like the James Webb Space Telescope or the Hubble Space Telescope. None of them can resolve the core of the comet. We can't really see the surface details there. I believe JDOST is 8M and Hubble is what? 1M. I totally forgot. Maybe I'm mixing up. But anyway, so Hubble is 1M, James is 8M if I'm right. But anyway, you can look it up. But this is what, 2025. So if you wait, or if we all wait until 2037, like 2032, 7 more years, they are actually making a telescope here on the ground, which is a 30M telescope. With that telescope, we should see the structure of the comet as soon as it comes into us. So that would be the time. I don't think we need to worry too much about how does it look. But for now, we are guessing about the structure and using the tools that we have. Here's where Ray brings everything into perspective. And it's a perspective that challenges the establishment narrative. Neither the James Webb Space Telescope with its 6.5M mirror nor the Hubble Space Telescope with its 2.44M mirror can resolve the actual surface details of 3I Atlas's nucleus. We simply don't have the resolution capability yet to see the comet's core structure in fine detail. Ray mentions that in 2032, 7 more years from now, the 30M telescope currently being constructed will come online. That instrument will have the resolving power to actually see the structure of comets like 3 Atlas in unprecedented detail. But here's the catch. By then, 3I Atlas will be long gone, hurtling back into interstellar space. So right now, in 2025, we're working with the tools we have, making educated guesses about structure based on brightness variations, color changes, and the fuzzy details visible in the coma. What Ray has accomplished here is significant, and he's demonstrated that independent researchers can contribute meaningful observations to our understanding of these objects. His 150-word commentaries throughout this analysis aren't just criticism of NASA. They're a call for more transparency and better science communication. When an independent astrophotographer working from his backyard can identify missing elements in a major space press conference, that tells us something important about the state of public science communication. The punch satellite imagery that existed before the press conference, the 400x brightness anomaly, the unprecedented color shift, the true scale comparison with Earth and Mars, the extremely rare close Jupiter encounter. All of these elements should have been front and center in NASA's presentation. Ray's work represents what's best about the modern astronomy community, the democratization of space observation. With relatively modest equipment and processing skills, dedicated amateurs can now contribute real data to our understanding of cosmic phenomena. The images recaptured showing that pointed core structure aren't just pretty pictures. They're data points that confirm what space-based observatories are seeing. This validation works both ways. It confirms Ray's observations are real, and it confirms the Space Telescope data isn't showing artifacts. As 3A Atlas continues its journey toward Jupiter and eventually out of our solar system forever, every observation matters. This interstellar visitor is giving us a glimpse into the composition and structure of materials formed around another star. We're literally looking at pieces of another solar system, and the data we're gathering now will be studied for decades to come. Ray's emphasis on the research opportunity is spot on. We need to maximize every telescope, every observation, every data point we can gather before this object disappears into the cosmic void. The broader message here is about scientific accountability and transparency. When independent researchers like Ray can identify significant omissions in official presentations, it strengthens science overall. It's not about undermining NASA or other space agencies. It's about ensuring the complete picture reaches the public. These agencies do incredible work, but they're also bureaucratic organizations with communication departments that sometimes prioritize messaging over comprehensive data sharing. Ray's analysis serves as a check and balance, ensuring that important details don't get lost in the institutional communication process. If you found this breakdown valuable, support independent astronomy research. Follow researchers like Ray who are doing this work not for institutional funding or corporate grants, but for pure scientific curiosity. Subscribe to channels that present data directly, that show you the actual images and calculations rather than just press release summaries. The future of astronomy isn't just in the big observatories and space telescopes. It's also in the thousands of dedicated observers worldwide who point their instruments skyward every clear night. As Ray continues tracking 3 Atlas, we're going to see more details emerge, more structures become visible, and hopefully more answers about this mysterious visitor from beyond our solar system.